Hello, everybody. Welcome to the Oracle Next Generation Real Application Clusters session. Today, we're going to be talking about scaling PayPal workloads with Oracle RAC. I'm Anil Nair. I'm the Oracle Real Application Clusters product manager, also the product manager for ASM. And there are some of the ways you can reach out to me. That specifically, Twitter is the best way. And we're going to talk a lot about workloads today and Oracle RAC features. I have talked about some of this in the past. So you would see some blogs in my LinkedIn and some presentation in my slide share. I am happy that PayPal senior engineer Pramod is going to be joining us. So I'm going to just let Pramod introduce himself. Welcome, Pramod.
Hi, Anil. Good to be here. My name is Pramod. I am part of database engineering team here at PayPal, and I worked in PayPal San Jose and Austin offices. So over the years, we focus on securing, scaling, and maintaining high availability of our database infrastructure at PayPal. And I have been doing this for over 15 years now, and I am part of deploying and scaling a lot of OLTP scale applications. And you guys can reach out to me on my LinkedIn.
Great. So you want to just say about PayPal, a couple of words?
Yeah, sure. So PayPal, as you all know, so we all use it. So everybody is really aware of PayPal. So PayPal has been growing over the years, and some of these numbers really shows the need of scaling our database infrastructure. So we take our 390 plus million customers and their requirements very seriously. So availability, scaling our infrastructure as per our needs, and then securing our infrastructure is really focus area here. And Oracle RAC has been helping us all these years with most of these requirements.
Thank you so much, Pramod. So as you can see, customers like PayPal and many of our other customers run different kinds of workloads. And this is a very small list of all our customers, mainly running OLTP, analytics, or even what we call as HTAP or hybrid transactional analytical processing workloads. And they have all been able to run this workload successfully on Oracle RAC without much changes. Okay. In fact, this is one of our customers who had provided this quote. It basically says, if you have not looked into the new generation Oracle RAC 19C yet, you have not experienced what RAC can do for you. And if you want to know more about this new generation Oracle RAC, there's a white paper and a presentation that I've done in the past that you can look at. And if you have questions, as I said, feel free to reach out to me. Oracle Real Application Clusters was released about 20 years ago, in 11.204 initially. It came out with more of the features that would help out with the scalability in the sense that you had this grid infrastructure, clusterware, tightly integrated. And over the years, we've been adding more and more features. As you can see, right up to 21C, we are both optimizing existing features and adding new features to ensure that you get the best scalability and availability and you protect your data automatically. So you don't need to do any changes to your application. This means that we are able to scale what we call as the typical traditional applications and this new application paradigms that have been in the last 5 years, like specifically IoT-based workloads or Kafka or blockchain and all those new paradigms that have come up into the development space today. Just don't take my word for it. You can see that this is actually an IoT workload, which is scaling on Oracle Real Application Clusters. So basically, IoT workloads are becoming more and more common now because you have a lot of these devices which send a lot of data that needs to be stored. So Oracle RAC, you can put some of this data into different instances and be able to scale. And you can see that with an array of 100, which is basically insert every 100 records. You can see that we get scaling, and as you increase the array, you can see that basically you can spread this across different nodes or instances and benefit from the scalability. Similarly, we have this queue-based workload, which is again a new work a thing that is used typically by developers. There is this concept of queuing and dequeuing, and as you can see, when you do this or spread this across multiple instances, because queuing and dequeuing is very dependent on CPU. So if you have a lot more CPUs spread across different nodes, you're able to actually do your workloads or process your workloads faster. Okay. So this is some of the things that Oracle Real Application Clusters does, but let's talk to Pramod a bit about what does a PayPal database implementation require, Pramod?
Yeah, sure. So as we all know, scalability, Anil briefly mentioned. So basically, as you add resources, the database should be able to scale without much overhead. So the overhead part is really important to us. So our customers cannot tolerate any latency. So this is really important to us. So availability, again, like the ability to detect the failures and make sure services are available is a key component of Oracle RAC, and we have been using it very well. So one of the key things over here is the detection and the level of identifying the failures. The scope is really wide here, right? So there is failures, database failures, network failures. Any sort of failures are identified by Oracle RAC most of the time automatically, and we also have our own engineered solutions to detect and then take the action accordingly. So all this is possible with Oracle RAC because of its architecture and ability to kind of able to fail over the services. So in fact, I think we have things like identifying public network failures and then sending the events of that nature. So all this is very important for us so that we can engineer our own solutions and take action accordingly to maintain high availability. Yeah.
Thank you, Pramod. So essentially, all the requirements that PayPal has, is pretty much fulfilled by Oracle Real Application Clusters. Because we can scale within an instance by adding instance and all of this without, any downtime requirement. Thank you so much. Anything about your database typical deployment, Pramod?
Yeah, so we have Oracle RAC databases. That is the center of our architecture. So you can see some of these numbers actually. So this is one of the busiest system on the right side, and across the databases, what we see is on the left side. So these are phenomenal numbers, as you can see. Overall, we are seeing like 15 million executions per second today, and then the growth is always there. So we are growing like 33% year over year on the database storage side. So we are almost looking at 90 plus petabyte of total database storage today. As you can see on the right side, one of the busiest and biggest systems we have deployed in our infrastructure. So it has like 4 node X78, 8 core. So basically 768 cores and then 8 socket machine. So this machine is doing like at peak 2 million plus packets it sends and receives. And then it's all being done within a latency of 0.25 milliseconds. So this is all possible basically. As you can see, these are like phenomenal numbers on one single rack system. And this is all possible because we have been doing a lot of optimizations over the year in collaboration with Oracle, and I think we will speak about that in a bit. But this is to give an idea about the scale we have and the numbers we are doing.
Great. Thank you, Pramod. So let's get to how does Oracle Real Application scale all these different kinds of workloads? So there are many reasons, but we'll talk and focus more about two specific ones. One is our differentiator, what we call is very unique and innovative Oracle Real Application Clusters Cache Fusion. So on the left-hand side, you could see that before Cache Fusion, if different instances need access to the same block, they have to be read from disk. So this is not the most optimal because, as you know, disk is perhaps, or disk access is perhaps not the fastest. And from 8i to almost 21c, you can see that Cache Fusion has been updated and having newer and newer algorithms to keep up with the pace, especially when you have this SSD disks and you have this high-performing network. Also, cache fusion, which is implemented by the LMS process. We have increased the number of LMS process. We have increased the priority of that. We auto tune the number based on certain conditions. So we do all this. And this is one of the reasons why we are able to scale workloads, and without requiring any changes to them. So this cache fusion optimization, you can see that there's a small list that I've put in here, but the main one that it helps is this we call it as the right growing index optimization. So right growing index is basically a very typical issue that you would see in a workload, because as you add more and more records, the indexes get a bit heavy on the right side for access. So we have implemented what we call as index split optimizations. We have scalable sequences and some of these other optimization that help with those kind of workloads. At the same time, on the right-hand side, you can see that we have this interconnect optimizations where basically we reduce and improve the resources that we use when we access network resources via this lightweight IPC. So on generic systems, we have improved handling of operating system resources like sockets, file descriptors, etc. And obviously on Exadata, which is our engineered system, we have been able to benefit from RDMA. So cache fusion speed improves to about, is almost less than 10 microseconds even under load. This is only possible because instead of having a processing-based LMS, which is sending and requesting data, we can actually let the foreground directly read it from the remote memory. Okay. Again, cache, as we are on the topic of Exadata, there is a whole bunch of optimizations. A lot of the RAC core code has been changed to benefit from RDMA. So we use RDMA for propagating broadcast and commits, current read blocks. I'm not going to read through the whole list because a lot of that has been already covered, as I said, in my previous slides. So let's move on. The second part is the part about effective and efficient and adaptive resource management. So what does this mean? Essentially, in modern database systems, you have the CPU, which over 20 years has improved the performance and the core processing capability so much. But what we have done at our end is to make sure that we take an advantage of these benefits. On the right-hand side, we see that internally in our memory structures in the global resource directory, a lot of our work has gone in to make Oracle database resource management adaptive to incoming workloads. Okay. So what do I mean by benefiting from modern CPU architectures? As you know, RAC was introduced about 20 years ago, where the typical CPU was actually a CPU, as I call it. Today, if you look at a CPU, you have a bunch of cores, and you can actually have threading. So what we have done is we have actually adapted a lot of our code to benefit from these newer CPU architectures. So you can see that now today we have these critical processes which benefit from, for example, additional threads. So LMS is having additional threads. Not only we do benefit from additional threads, we also optimize their priority based on this. Similarly, if you can look at not just LMS, the other critical process like GCR, we make sure that we have threaded. So we have broken down this bigger process components into leaner threads, which can benefit as more cores are added to the system. All this actually helps significantly to 19C RAC availability, because now you can see that between 11G comparison to 19C, we have a 7x reduction in reconfiguration time. And there is a lot of feature that goes to help with that. I'm not going to read out all that, but some of them like Recovery Buddy, which we are going to talk about, and all those help reduce this reconfiguration time. Since we are going to talk about reduction in time, let's get and ask Pramod what are some of the things that they use in terms of with RAC, like zero downtime for patching. Pramod, do you have anything to add to this?
Yeah, sure. So as we mentioned, so high availability is really critical at PayPal. So we achieve this by using Oracle RAC. So our software lifecycle management, the heart of it is Oracle RAC, because we patch our software in rolling fashion using Oracle RAC. So the downtime is minimized here because we move the services to other available instances. And one of the biggest problems was downtime. Basically, during the reconfiguration, there is a freeze, and then that causes application impact. So that is one of the problems. So with all the optimizations Anil briefly mentioned, and we did on our end, over the years, we are able to really cut down on that downtime, and then we are looking at really close to zero downtime planned maintenances. So here, Oracle RAC played a significant role, along with the optimizations we did for reconfiguration.
Thank you, Pramod. So these are some of the numbers, I believe. You want to talk a bit about it?
So these numbers can highlight. So on the left side, so this is a journey. Over the period of time, we went from 50 seconds, so that was 11G without much of optimizations on the software side, and then some of the features we did not use back in the day. During that time, it was 50 seconds, and our PayPal engineering team, in collaboration with Oracle team, worked together over the years. And then, as you can see, on 11G itself, on 11204 itself, we were able to achieve 20 seconds of reconfiguration times, which is a significant reduction from 50 seconds. And then this is on 11204, remember, right? So there were many special things we used on both software side. Some parameters we got from Oracle, so really helped us moving the ball. And then on 19C, as you can see, I think Anil will go through a lot of features. So as he briefly mentioned, there are a lot of optimizations out of the box. 19C Exadata, so we are able to get less than 10 seconds out of the box. So which is significant improvement compared to 11.4 also, which was already like 50% down from where it was. And then out of the box, if we are able to achieve 10 seconds, which is really helping us.
Great. Thank you so much, Pramod. You want to talk about a bit about the optimizations which helped reduce the reconfiguration time, specifically at PayPal?
Yeah, sure. So these are some of the very typical things we did in collaboration with Oracle over the years. So PayPal engineering team, few folks from our side, and Oracle RAC team, a lot of folks work with us. So I think few things I will highlight here. As you can see, improvements over the years, and then we were able to go down below 10%, and all that happened. So some of the things I can highlight here are, so as you can see on the right-hand side, the LMS processes play a key role in handling all of this. So we did several optimizations, as I mentioned. So what we noticed is having good number of optimal LMS processes, reducing the reconfiguration time drastically, right? So some of these things are automated in latest versions, but we started doing it back in the day in collaboration with Oracle. So obviously that number is should be optimal. We don't want to overwhelm our system. At the same time, we want to achieve good reconfiguration times. As you can see, startup and shutdown reconfiguration times went down drastically. And then some other things I can say, and we do today, even today, is we reduce the cache during our planned maintenances. So before we shut down the instance, instead of increasing the reconfiguration, so we use our automated program to gradually reduce the cache after recycling the connections. That way, the number of DLM locks will be minimized, and the total reconfiguration uh, uh, basically comes down. So again, like some of these things you have to plan for your environment. In our case, we were seeing like 1 TB of cache. We were able to shrink within 20 minutes because our downtime is more important than the patching time. So we go with this approach. And again, as I said, like Oracle 19C, all these optimizations on the LMS process side, and then other areas have been happening out of the box, and then there is an improvement already.
Great. Thank you so much, Pramod. So continuing with, we have improved some of the operating system like memory and huge pages. So in the later releases 19, you could see that we are always using huge pages as much as possible. And I keep saying as much as possible. The alert log tells you how many pages we have and what we can use. We also use the benefit from the underlying improvements to the NUMA. So we detect NUMA and we make sure that processes are scheduled on the right NUMA nodes. Moving on, same with networking. The private network, as you know, is what we use for our cache synchronization. So we detect UDP, and then we use the lightweight IPC to make sure that we can benefit or reduce the number of operating system resources. Continually, while we detect these things during startup, we also continually monitor some of these things. For example, we have this DRF feature, which is basically a database reliability framework feature, so that we adapt to changing workload. So, for example, DRM, and dynamic resource management, which is the ability of cache a resource monitor to move from certain node to other node. We have made sure that it doesn't happen when there is lesser CPU or the CPU resource is a bit hard to get. So as you can see here, we say, okay, we check out, should we disable DRM because the CPU load is high? Should we enable DRM? What? And also, we make sure that if the interconnect or network is congested, the private network, so we kind of monitor that and make sure that we take some adaptive action based on this. This is an ongoing thing. We try to adapt to changing workloads, and we do let the customer or the DBA know via various $V views. This information is exposed so that the DBA can follow up and find out why a certain event happened. Okay. As Pramod mentioned, we have come up with this a small list of features that we kind of highlight every time. It's not just we introduce the feature, we continue to improve and improvise the feature. For example, when multi-tenant came out, we had this requirement that, hey, if you have multiple PDBs, you want to make sure that these are isolated. So if there is two PDBs on a system, one PDB doesn't overwhelm the resources of that host. So we kind of provided or made sure that Cache Fusion provides complete isolation between the PDBs. It's also secure because now the yellow PDBs cannot see the data from the red PDBs. We have another unique feature, as you can see on the right-hand side, which is the hang manager. The hang manager actually detects and resolves both hangs and deadlocks. So if an application program by mistake has some faulty code that causes hangs, we would actually detect it and resolve it. On the left-hand bottom, you could see that we also work with this reconfiguration time or reduce this reconfiguration time with recovery buddies. Essentially, instead of trying to detect a master node to restore or recover from some of the crashes, we actually pair them up with a recovery buddy, which drastically reduces the reconfiguration time. On the right-hand side bottom, you could see that we do also what we call as the smart fencing, which is essentially we kind of determine that the majority of the work is running on a certain node. So if there is what we call as a split brain, we make sure that the node which has the majority of the work survives so that the customer workloads are not affected. Now, since we are talking about split brain and what we call as node evictions, let's see how does it help out with customer workloads. So when the customer workload is running, typically what would happen is you'll have a bunch of users who are connecting via some kind of pool, and this pool of connections is going to be talking to a database. Now, in Oracle Real Application Clusters, we have this concept of SCAN, or what we call as single client access network. The single client access network also makes sure that the workload is balanced across all the instances, and it has different capabilities to load balance both client connection-based load balancing and rule-based runtime-based load balancing. Excuse me. So we do all that. Now, if the client, the scan says, hey, this one connection request we need to go is redirected on a certain node, and if by any chance that node itself crashes, regardless of during the initial connection attempt or during normal operations, we would initiate what we call as a gratuitous ARP, which will update the ARP table and redirect the connection immediately to another available node. So the client doesn't wait for what we call as a TCP timeout. Now, this is very important because remember, there is no change to the application code. All this happens in the RAC layer. So this is automatically something that they benefit from. Or more importantly, the connection pool is also notified that, hey, that node number on one is actually down. So please don't send anybody there anymore. So this is like the the way that we make sure that it's not just the database, it's not just the instances, but also the client session, the database client sessions that also benefit from this information. Okay. Sorry. So now that we have this client failover, I would like to go back to Pramod to see, hey, how does PayPal implement the routing of sessions to particular instances? Pramod, can you please add some more here?
Yeah, sure. So as you can see, our scale, some of the key metrics I have mentioned here. So in some of our systems, we see like redo of 300 megabytes per second. And we have like 200 MB per second of interconnect traffic, and then 50K IOPS, 5 GB writes, and all these numbers are happening on some of our systems. I think most of you might be familiar, like on some of the RAC systems, we typically when you have this kind of write traffic, there is a write contention and some other RAC specific contention may happen. So we all try to reduce that overhead. So basically, uh, scaling such numbers so as we grow is really important for us. So one of the things we did, this is even a few years ago. So we started using our own sharding. So basically, as you can see here, so the application microservices are sharded. So so within our connection layer, and they are routed according to the target database. So as you can see, we leverage RAC services really well here. So some of the read-only services, read-only traffic is routed to some copy, and then read-write traffic. Within read-write traffic, again, like we peek the key and then send the traffic to particular target database accordingly. So in some cases, full copy is maintained, and that copy can be used as read-only service. In some other cases, it is actually real sharded database, and then with this our own logic and engineering, we were able to reduce the writes coming into the database. So this is how we scale. And then again, like so another thing I would like to mention. So on a particular RAC database, we also have ability to split reads and writes. Uh, so again, like we look at type of query in our application and middleware, and then we route read traffic to multiple instances. As we know, like read traffic scales across multiple instances. Write traffic uh, can be routed to single instance. So I think some of the features will be mentioned by Anil in next slide. So these are all to handle typical write contention like sequence contention or other write contentions we see at scale. Uh, uh, so with these typical features, we were able to handle those situations. So most of these things are handled at small scale, but when you look at this kind of scale, or when you come to this scale, so these are some of the things we do to scale our systems.
Thank you so much, Pramod. So now that we talked about some of the what we call as optimization customizations that we have done, let's look at what we have done for generic RAC customers in the area of scalability. As I said, similar with HA options or high availability options, we have continuously improved scalability options. So we have this optimized singleton workload scaling, smart cache fusion to dynamically monitor and determine the optimal path. As I said, 20 years ago, rotating disks were the norm. Today, we have SSDs, we have a storage that can actually read and write much quicker. So we have optimized our cache fusion algorithm to monitor and dynamically choose an optimal path. Similarly, we have our pluggable database optimization, where we make sure that via an in-memory separation, the lock manager of cache fusion can optimally send and receive messages, so they don't have to send it to all the other PDBs. Finally, we get to this service-oriented buffer cache. Now, what is service-oriented buffer cache? So what we do in RAC is we try to maintain the relation between the access patterns of different nodes. So if you see this, essentially what we do is we try to make sure that the buffer is automatically updated with the typical workload that it's running. So this actually makes sure that a lot of the workloads, if you have a stable workload, we would see that the performance benefits of that workload would be very much similar to what you'd get on a single instance. This is because Oracle RAC in the background maintains what we call as a relationship between the buffer cache and the instance which is running, which is also persisted to the database. So if you restart your system again, you would see that by default, we would say, hey, table sales was accessed by a lot of workloads on node 3 or instance 3. So let's make sure that this cache is having a lot of information about that table sales. So this is a very interesting feature because this helps a lot of typical workloads, especially in the case of PayPal. Pramod, you want to talk a bit about how making sure that the buffer access is local helps with performance?
Yeah, sure. So again, uh, this is one of the hard systems we have, but still you can look at the latency numbers here, and then so yeah, this is highlighted here. So buffer access, you can see still above 97%, 91%. So that is because of all these features. So we are able to retrieve everything out of buffer, and node access and disk access is very minimal. So these are all helping us, and local buffer access is really key. That is as good as a single instance database, right? So that is really key, and this is showing like the overhead of RAC is getting very minimal actually.
Right. Thank you. Thank you so much. Something about your customization in response to the DBMS cache util?
Yeah, sure. So as I said, like this has been a journey, and then we are on 11.204, 11.202, and then now we are on 19C. Still, some of our very critical systems are on 11.204. So these are typical optimizations we did on the rack specific to rack. So as I said, like we have really kind of we were handling reconfiguration is one of the biggest things we were handling because that directly translates to business impact. And then we did some optimizations and around dynamic remastering DRM. So I'll talk about these things. So for planned maintenances, as I said before, few optimizations we discussed about LMS processes, shrinking the cache and all that. And again, like this is one of the things we did in the past, and we do for some systems even today, is actually you can use this utility provided by Oracle, and this is to grab the affinity. So basically, as you can see on the left side, so your mastership is distributed across the instances. So, so basically, this DBMS cache utility, there are some procedures, and you can grab the affinity and then bring those to the local node before you go with the maintenance. So basically, you clean up that particular cache before you go with the maintenance. And then again, like your mileage may vary depending on how you use your application. Your services are kind of distributed across the instances. The timings may vary. And again, like as I mentioned, like DRM. So we really want to reduce the unplanned maintenances. As I said, planned maintenances, we came up with all these series of things we can leverage during planned maintenances, and we keep on inventing new things along with Oracle to leverage during planned maintenances. But unplanned maintenances are really, we cannot take any unplanned maintenances because of direct business impact and dollar impact. So, so DRM, there are some options around DRM to reduce the kind of, we can disable the DRM, and then there is undo DRM. We can control that. So again, you can check with Oracle and get some parameters specific to your environment. But basically, a lot of DRM optimizations we did in our environment, such as disabling the DRM and then optimizations in undo DRM area, significantly reduced our reconfiguration times. Uh, Unplanned maintenances got better because we disabled it, and then planned maintenances also we leverage all these features, and then we are able to minimize the downtimes overall.
Yes. Thank you, Pramod. So just to reiterate, I think one of the key takeaways from this slide is that, if you do or work with us closely enough, there might be some benefits to disabling DRM. This is by no means the recommendation. Your mileage might vary, right, Pramod?
Yes, definitely. Our requirement was to eliminate unplanned maintenance outage. So again, our services, as we mentioned before, We have a lot of read-write split within our own architecture. We have several things, so we distribute services very differently. So it is definitely specific to your environment, and definitely talk to it.
Thank you. Thank you. So you want to summarize?
Yeah, so I think I would say so RAC provides us high availability with multiple nodes. We are able to maintain our RAC software or Oracle software effectively during software lifecycle management. We are able to scale by adding additional resources without much overhead. So that is the key, right? So I can add another node, but I cannot take much overhead. So all these features and then software improvements have been helping us to scale. Within the rack systems, continuously there are improvements to detect the failures and leverage the redundancy. So even if you have redundancy, software should use it, right? So Oracle RAC has been doing most of the things automatically nowadays, and then it gives us the abilities, like it publishes the events, and then we are able to engineer our solutions using all these features. And again, like let's say like very basic thing like scan and service is like a big deal, and we have been leveraging different service architecture to scale our environment, to scale our complex workloads.
Thank you. Thank you so much, Pramod. Now that we have talked about what does current generation or what we call as a new generation current version RAC does, let's look at a brief preview of 21C. I promise not to take a lot more time, but I just want to make sure, some of the things that Pramod talked about, how we have, got that feedback, worked on it over the years, and tried to see what are some of the new things that could help customers. So one of the things we are working on and we've been worked on for a long time is this zero downtime grid infrastructure patching. This is the ability to patch an instance or a node without taking down the stack on that node. I know we talked about it for a while, but we can pretty much say that the general availability is with 21C with RU and RUR support. Similarly, we have also reduced the chances of an LMS crash, which is the ORA 481 error, by trying to retry and recover from unexpected states instead of going through the complex process of crashing and reconfiguration and all that. So this is something which will even help improve your high availability. Finally, Pramod talked about some of the features that they do, like this DBMS cache, DBMS util to grab affinity. Well, guess what? In 21C, we have automatically tried to move some of these so that if you pay attention, so suppose you have to say, change node 3 or shut down node 3 for some reason, before when we shut down something, we actually try to remaster some of those resources away so that the whole time taken for the planned maintenance is even more reduced. So these are some of the features that is going to come out soon. This is just a sneak preview. Obviously, there are a lot more features, and as 21C comes out, we'll talk more about it. But that's pretty much all I have today. Just to take away some of the key messages. Putting your database applications, whether they are on the new application paradigms or the package application, you'll get benefits from RAC. There's a whole bunch of benefits I have put out here. Automatically you're available, scaling within an instance, adding instance. You don't have to change any application. We benefit from a client application failover, connection load balancing. If you have analytics running, you can scale by using in-memory because Oracle RAC with in-memory scales. And then, if you have this microservices-based architecture, definitely multi-tenant, we can scale that. All you get with, complete isolation in converged environments, all with security. So I would say there is, a lot of benefits for Oracle RAC. At the end, I would like to take a minute and thank you specifically from the Oracle RAC product development team and Pramod and PayPal's engineering team to work with us together so that we could come up with this presentation. Thank you so much, Pramod, for having us. At this time, if you have any questions, let us know. Until then, thank you so much.
Thank you very much. And we highlighted some of the things, so please do reach out to us if you have any questions. And then, as usual, looking forward to collaborate again, Anil. And thank you very much.
Thank you.